In this section, we're going to discuss quadratic functions. We're going to take a look at what makes a function quadratic. We're going to look at the standard form for a quadratic function, the vertex form for a quadratic function. We're going to look at completing the square, finding formulas for parabolas, finding zeros of functions by factoring, completing the square, and the quadratic formula, the vertex and axis of symmetry, and application problems. So as we first start, let's look to see what makes a function quadratic. A function is quadratic if it can be written in the form f at x equals ax squared plus bx plus c, with a not equal to 0. A quadratic written in this form is said to be in standard form. So in order to be quadratic, we have to have a squared term, and that squared term will have to be our highest power of x. We could discuss things that are what we call quadratic in form, but we're going to just for now deal with functions that are purely quadratic. Remember, the graph of a quadratic function is called a parabola. And I have drawn two parabolas, and they tend to be the basic shapes that we would see for a parabola, either the concave up version or the concave down version. But of course, they could be located any place in the xy plane. Just I drew them slightly in to the right so that it appears that the vertex is in the right side of the rectangular coordinate system. So, speaking of the term vertex, let's give a couple of terms that we're going to be using in this particular section. So first of all, the vertex of the parabola is the maximum or minimum point. And so on this particular parabola, the vertex is located right here. And on this particular parabola, the vertex is located right here. And so on this one, it's the max. And on this one, it's the min. And that'll be an important point, that when we have a quadratic, the vertex is either the maximum or the minimum. Every parabola has a vertical line of symmetry which passes through the vertex. This line is called the axis of symmetry. So on the first parabola that I have, there's our axis of symmetry. On our second parabola, there's our axis of symmetry. So let's just label those. Notice those particular lines that are the axis of symmetry are in fact vertical lines, and so they will actually be of the form x equals. And so in this case, it appears this vertex is at x equals 2, but which makes the axis of symmetry x equals 2. And at this one, it appears that the axis of symmetry is at x equals 3. The vertex is when x equals 3. And so in fact, if I wanted to, I could label the vertex. This appears to be 3, negative 2 for the vertex. And this vertex appears to be 2, and then let's see, 1, 2, 3, 4, 5, 6, 7, 8 maybe? And then the last piece of information I want to talk about are the zeros. The zeros of the parabola are the x-intercepts, and they are the places where the function equals 0. So if I were to be looking at these particular parabolas, here are the zeros. Now, I don't really have enough information to either be able to read them off or to compute them, but those would be the zeros. And so the zeros are the places where the function equals 0. Those are the x-intercepts.